Hi, I'm Elior Sulem from the University of Pennsylvania, and we talk today about yes, no, or I don't know, the challenge of unanswerable yes-no questions. In order to know whether a claim is true or false given a context, one way is to ask a yes-no question. For example, given the context, Jane, who is a native of Los Angeles, married a lawyer from New York City, we can ask, did Jane marry a lawyer? Whose answer is yes. We can also ask, was Jane born in France? Whose answer is no. And this task was formalized in Clark et al. 2019, who released the BoolQ dataset that includes paragraphs together with naturally occurring questions whose answer is either yes or no. However, in practical situations, we don't always have the information required to answer the question. For example, given the same context, we can also ask, did Jane marry in New York City? In this case, we expect the system to answer, I don't know. In this work, we extend the yes-no QA task, making it more natural, first by augmenting BoolQ with unanswerable questions, but also by compiling out-of-domain test sets. We show the difficulty of the new tasks compared to the two-label setting, both when training on the task-specific data and when leveraging other natural language understanding tasks. To augment BoolQ with unanswerable questions, we use the existing questions and paragraphs from BoolQ, and for some of the questions in BoolQ, we match them to passages that have the greatest overlapping with the questions in terms of nouns and verbs. We apply this process on both training and dev sets. The idea is to have relevant questions, but still with an I don't know answer. For example, here we match the question, do they make a new Lombardi trophy every year, to this context that has a lot of overlapping, Lombardi trophy, year with a question, but still the answer is I don't know. So we obtain these questions and we add them to the original BoolQ dataset, obtaining the BoolQ 3L dataset with 3 labels. We validate it manually, showing that the noise is very small, with a high inter-annotator agreement. And we also compile out-of-domain datasets, in particular a test set that is derived from the ACE event extraction dataset. We focus on time and location arguments, and we derive both as-answer questions and I don't know. For example, given the context, the World Bank offered a loan in 1999, and the as-answer question is, did the offer happen in 1999? And an I don't know question is, has the loan been paid? We also compile a small instruction-based corpora, so questions about instructions, where we also have as-answer and I don't know questions. We first show the difficulty of the task when we train on the new dataset. We use a BERT-large system, and we see that the performance on the dataset is very low compared to the two-label setting when we train and test on the original BoolQ, and we see a similar behavior on the out-of-domain test sets. We see that if we also train on textual entailment data on MNLI, it improves the performance, something that was also observed in the two-label setting. We also see that when we use the binary version of textual entailment, it even further improves the performance, also in the case of the three-label and two-label settings, but still we have a large gap between the three-label and the two-label settings. So to conclude, we claim that if we want to use yes-no QA in realistic scenarios, we need the ability to answer I don't know. So we extend the existing yes-no QA benchmark by augmenting BoolQ with answerable questions, and also by compiling out-of-domain test sets, in particular test sets related to event extraction. And we show the considerable difficulty of three-label yes-no QA compared to a two-label setting. The data, code, and pre-trained models can be found at this link. Thank you very much for listening.